Hello guys, this is Paul McWhorter from TopTechBoy.com, and we are here today to learn Fusion 360 or to die trying. What we're going to learn today, this is going to be lesson number 6 in this series, and this is going to be one of our most important lessons. And in fact, if you're only going to watch one lesson in the series, this is the lesson that you're going to watch, and what you should watch. What we're going to learn today is we're going to learn how to do parametric design. Again, we did parametric design in lesson number 5. We're going to continue and do parametric design again in today's lesson. But what we're going to do is we're going to learn how to start designing something that has a little bit of three-dimensional complexity. I think if you've been through the first 5 lessons, at this point you're probably fairly comfortable doing a design where you would sketch something on your XY plane and then extrude the design out of that. So something like this eyeglass case that we did in lesson number 5, that's something, or things like that, that you should be pretty comfortable with at this point. But what we're going to talk about today is something that would have a little bit more design complexity. And let me get out of your way here. And if we look at this design here, let me move it over. What you can see is that the case, the box, is a lot like our glasses case, but now if we put a hinge on it, we've got to extrude the hinge from a different plane. So you can imagine if you pop over to a different plane and start drawing on that, somehow magically you have to have that drawing align with something that was extruded from another plane. And you can even see in this case that we would draw this down on this plane, and then we could draw this on a horizontal plane, but this isn't even intersecting, this body isn't even intersecting the plane that we drew the box in. So all of a sudden, if you're not careful, you can just end up with parts drifting out in space. And so we've got to be very, very deliberate in this design. Now this is a fairly simple thing. I chose something like a box because it's something you understand, and I can take you through it, because what I want you to understand here is getting things to align when they are sketched on different planes. Okay, it's this three-dimensional alignment from different planes. That's the skill that we're going to learn today. And I'll tell you, one of my frustrations with Fusion 360 is I'd sit down and I'd try to learn this, and I'd kick off a tutorial. It's like, okay, today we're going to design the International Space Station, and okay, here we've got the reverse osmosis cog, and it's just like, whoa, I get so lost. And there would be so many different tools that they would be using, I couldn't get the fundamentals mastered. I couldn't get the basics mastered. And so with this, if you will learn how to do these alignments, you will really find yourself being successful. And so this is going to be a little bit longer video than the ones that we have done in the past, but it's a really important one. If you get if you don't have enough time, pause it, come back later. But I wanted to kind of include in one video, start to finish, a complete design that has three-dimensional complexity that requires us to figure out this three-dimensional alignment problem, and something that's simple enough that you can understand the design that I'm doing and not overwhelm you with some of the more advanced features of Fusion 360. Okay, let's review. You win or lose the battle of 360 at the sketch plane. What do you have to do in all of your sketches? You have to be mindful and you have to be deliberate about dimensions, about position, about constraints, and now the fourth thing that we learned in the last lesson is about parameters. And believe me, if you design with parameters, it might seem like it's slower at first, but you're going to save time, because you're not going to have to end up throwing your design away and starting over and continuing to have to redraw things. If you use parameters, it will be the biggest time saver ever. It's just by doing parameters, it seems like it's a little slower, because you got to start by kind of thinking through your parameters. But using parametric design is like forces you to think about your design before you start. So enough of this nonsense. Let's jump in. Let's go ahead and I guess before we fire up a new thing, let me just look here. Before we jump in and start defining our parameters, let's just think about it. What are two really obvious parameters that I would need? I would need width and I would need length. Okay, there's a top and a bottom. Is that going to be 4 parameters or 2 parameters? I could have length and width, or I could have top length, top width, bottom length, bottom width. This is so important. It sounds obvious, but this is design intent. This is what you have to think through. You might want a wide box. You might want a narrow box. You might want a tall box. You might want a short box. You might want a long. You might want all these different things. But what do you always want? You always want the lid to fit on. So what does that mean? Length and width. That's 2 parameters. Okay, 1 parameter for length, 1 parameter for width. All right, what are other parameters that we're going to have? Well, I'm going to have a height of the bottom, and I'm going to have a height of the top. Those are 2 parameters because the bottom might not be the same as the top. So you're going to give yourself 2 parameters there. Again, I'm thinking through it. If you always wanted it the seam in the middle, the break in the middle, then the height would be 1 parameter. But because I want them independently set, it's going to be 2 parameters. What else do I have? Do you see how I have a little lip on there? Can you see the little lip? Okay. There is a lip height. Okay, there is a lip height on the bottom, and there is a lip kind of like how far it's recessed on the top. That dimension, is that 1 or 2? Okay, that's 1 parameter, because if this little lip gets taller, this little lip here better get deeper. You always want them to match. So lip height is 1 parameter. What else do I have? I have some rounding on the corner. What is the radius of that rounded corner? That's going to be a parameter. What else do I have? I have wall thickness. Okay, wall thickness. And then the wall thickness is the whole thing. And then I have the lip thickness, the little thin lip. How thick is that? All right. Now, if you think wall thickness and lip thickness, you might want any different wall thickness, but is lip thickness dependent or independent? Would you have any old wall thickness and any old lip thickness? No. You would want the lip thickness to always be half of the wall thickness. Why? That way it's always going to close and fit together. Okay. What other parameters are you going to need? I'll have to switch over here. And if I switch over here, I am out of your way. That's good. All right. You're going to see that we're going to have some parameters associated with the hinge. Okay. The first thing that you can see that you will have associated with the hinge would be the hinge diameter. And then there's a hole in the hinge, so you would have a hole diameter. So those are 2 parameters. What is another parameter? Another parameter would be, this is a very important one, and you got to think about it, because I wouldn't want the hinge to go from here to here, because you would have this goofy spot at the round corner where the hinge is just kind of hanging out in the middle of nowhere. And so really what I want the hinge to go, I want the hinge to go from the start of the flat part to the end of the flat part. So I'm going to need a parameter which is like the flat dimension, like from here to here, and that's going to depend on both the width, and it's going to depend on the amount of rounding. So what would it be? Well, it would be the width minus the curve radius, the corner radius here, minus the corner radius here. So it would be the width minus twice the corner radius. And now, no matter what size I have the box, I've got a dimension of this flat part, which will be the extent of the hinge. Now, what else do you see? You can see that this part of the hinge is tied to the bottom. These 2 hinges are tied to the top. And you've got to decide what fraction of this flat part do you want to be dedicated to top hinge, and what fraction do you want dedicated to bottom hinge. Well, with parametric design, what you can see is you can see something real quick, that one is going to depend on the other, because what I know is that the fraction dedicated to the top plus the fraction dedicated to the bottom had better equal 1, or a total, okay, a whole. So I've got to kind of decide that, what fraction, and you can see here I put too much on the bottom and not enough on the top, and so I would want to do this, design this time parametrically, and I could kind of adjust that to be just right. Also, you could imagine you would not want this dimension of this hinge the exact dimension of the gap, because then it might be kind of tight, it might jam in there. So you probably want a little bit of a gap tolerance. All right, so we've spent what, 5-6 minutes talking about parameters, but man, we're just going to be going crazy here when we get our parametric table done, because it's going to go so fast. I am going to be deliberate to come back so you can see my design space. And now we are going to fire up a new design. So we come up here and we say new design, and we are not going to start drawing. We are going to put all of our parameters in. I know you like to jump in and start drawing like a madman or a madwoman, but no, we're going to put our parameters in, and then it is going to be fun to start drawing, because we're already going to have all the things that we need already input. How do we put our parameters in? Under modify, you come up, and then you come over and you say change parameters. Okay, these are our user parameters. This is a new file, so there's no user parameters, and so we say plus. We're going to add one. What is our first parameter? Well, let's make it the width. Okay, so we're going to say width, and I'm just going to kind of take the dimensions off this box from an earlier design, and it looks like I have a width of 65 millimeters. 65. All right, what is the next? The length. Okay, so we're going to say add a parameter, and we are going to call it length. Okay, and the length, it looks like I am set at about 45 millimeters. So we will put that at 45. All right, that is great. We've got the length and we've got the width. When we're thinking about this, what should we always go ahead and put in? How about that corner roundness? So what we're going to put in here is corner radius, and I'm going to put that in as 4 millimeters. That sounds good. Okay, that looks good. So I've kind of got that profile pretty much defined. Now what do I want? Well, I should probably go in and put in my bottom height, and my bottom height goes from the bottom up to the little ledge. The bottom height does not include the lip. Okay, it's just the bottom part without the lip. So I'm going to say bottom height, and that is going to be, it looks like, that's going to be 32. So I'm going to put the bottom height at 32. And then what would be good to do now? You guessed it, top height. No spaces in these names. Top height. And the top height looks like it is going to be 16. Okay. Wow, I'm getting a lot of progress made. As we're doing heights, what other height should we do? We should do the height of the lip. The height of the lip. Is that lip height one parameter for the bottom and one parameter for the top? No, it's just one parameter, because if this lip gets taller, you need this lip to get taller to match it so that the box always closes. So you see, I'm doing design intent. I'm defining these parameters so that no matter what parameter you put in, you end up with a box that fits together and operates the way that you want. And so we're going to say lip height, H-E-I-G-H-T, and I'm going to call that 2 millimeters. Okay. Now, what else do we have? We have a wall thickness. What is the thickness of the whole wall? Thickness of the bottom, thickness all the way around. That should be the same, so one parameter. And I'll call it wall thickness. Okay. And I'm going to call that 2 millimeters. And then if I have a wall thickness, what else do I need? I need a lip thickness. Now, is lip thickness a dependent variable or an independent variable? Can you just go pick out any lip thickness you want? No. Lip thickness is related to wall thickness. The lip should be half of what the wall is. So it is a new parameter, and I will call it lip thickness. All right. But it is going to be equal to wall thickness divided by 2. So what that means is that if whatever thickness I make the wall, which is what I would want to design to, I'm always guaranteed that the lid is going to snap on nicely. Okay. Think through this. Think how you want this to work. Setting up the battle is won or lost a lot of times in setting these parameters up right. Okay, that's pretty good for most of it. The one thing that we still need to do now is, and I'll make sure to get us back on the right view here in just a second, we need to think about this flat dimension. Okay, how wide the flat part of the box is. Well, it's the total width minus this curvature minus this curvature. Okay, so let's see if we can put that in, because this is going to be a really important parameter for us. This is going to be flat width, the width of the flat, and that is going to be what? The width minus 2 times the corner radius. Okay, and when we start extruding those hinges, this parameter is going to be very valuable because it'll allow us to know how far to go out. Okay, what else do we have? Let's see if we can come back over here. What fraction of the width that I have to work with, what fraction do I want on the bottom hinge, and what fraction do I want for a top hinge? All right, that can be set many different ways, but what do we know? They're dependent on each other. So I'm going to start with a new parameter that I'm going to say the bottom fraction. Okay, and let's be fair, let's put it at 0.5. We'll put half of the space that we have for the bottom hinge, and now we will have what? Top hinge. Okay, and this would be 0.5 as well. Right? Wrong! Because if I set that, if I changed one and forgot to change the other, it wouldn't work. Okay? I have to build in a constraint in my parameters so that it always fits together. So what should the top hinge be? The top hinge should be 1 minus the bottom fraction. Okay? And now the fraction that goes to the top and the fraction that goes to the bottom is equal to 1, and so we utilize 100% of the space that we have. And I think that I just made a mistake, and yes, I did. I'm glad I did, because, well, I didn't mean to, but if you look, we got to pay attention to our units, and I can't edit those once I've done it, but we need to erase those things that we've just done. Okay, how come? Because those are not millimeters, those are no units. Okay, so we're going to come up and we said bottom fraction, and that is going to be 0.5. Okay, and then we are going to add another one, and it is going to be top. Did I do that again? Oh my goodness. I'm going to pay attention this time. Focus, man. Okay, this is bottom fraction, and this is in no units, and this is 0.5. All right, and now we do the top fraction is in no units, and it is going to be 1 minus bottom fraction. Why do I do it that way? I do it that way so that if I want more hinge on the top or more hinge on the bottom, I change one number and the other one adjusts, so that I'm always guaranteed when I print this thing out that the hinges are going to fit together. So I'm building in this design intent into my design. Okay, what else do we have? All right, well, we have the radius. Okay, so we have the radius of the hinge. So I'm going to say hinge radius. All right, and that hinge radius, we'll put it at 8 right now. All right. Okay, hinge radius is 8 millimeters. And now we also want a hole. You know what? We need to edit that because that is not a radius. And we got to be very clear on this. That's a diameter. Hole or hinge diameter. And Fusion 360 works in diameter, so we got to make sure that we use diameter, we name things diameter. All right, naming things good is very important. Shouldn't have closed that. Okay, hinge diameter is still there. Let's add another one. This time we're going to say hole diameter. Is that independent or is that dependent? Well, you can make it independent, but really if you think, you always want the hole to probably be a little bit more than half of what the whole thing is. So I'm going to set it as a dependent variable. And let's say I'm going to put it like 0.65 times the, what was it, the hinge diameter. 0.65 times the hinge diameter. That's in millimeters. Boom. All right, let's come back over here and let's see one other thing that I probably need is I probably need to decide that there should probably be a gap here, right? Because I wouldn't want this dimension to be exactly the same size as the gap. So I'm going to create a parameter and I am going to call it hinge gap. Hinge gap. And I'm going to call that 0.1 millimeter. All right, so that gives you just a little bit of gap in there. I will use that as I build the design to put a little bit of a gap in there. The only other thing that you have to think about is the pin. You have to think about the pin that is going to go down into this to hold it all together. And I probably don't want to make the pin exactly the whole diameter because then again it might jam. And so I will put another parameter in that just say the pin gap. Okay, so I'm going to say the pin gap. And that I'm going to put, like, again, we're in diameter, so I'm going to put it at 0.05 because it's going to put it on one end and the other end. So 0.05 would be 0.1. It should fit then. So 0.05. All right. Hopefully that should be 0.05. All right, and I'm sorry, let me get back over here where you can see me. Sorry. Pin gap is 0.05. All right. I think I've got the parameters now that we need to really get started. Sometimes when we get in here, we'll see that we needed another one, but we can come back later and add it. And hopefully it'll start making sense why I did some of these things, particularly associated with the hinges. But let's get started. What do we want to do? We want to create a new sketch. So we say create sketch. All right, what it does is, where do you want to draw? I like to draw in the XY plane because I'm a math teacher. I work in the XY plane all day. Why is the other reason I want to use the XY plane? Sometimes for 3D printing, it's a more natural orientation because it sends it to the printer in kind of like that orientation. So let's click on the red, green. That is the XY plane, the red axis, the green axis. That plane is what we want. And what do we want to do? We want to draw a rectangle. So what do? We type R, hover over the origin, let it snap to it, click once, drag, click again, and now what do? We dimension. Type D on the keyboard, just click D, we get the dimension tool, we come out, and we put in 65, right? No! What did we just spend 20 minutes doing? Setting our parameters up. This is what? Width. Okay, boom, boom, and it puts the 65 in for us. What is this? Okay, this is length. Okay, and it puts the 45 in for us. Look at that. You see, we're already taking advantage of these. What's the next thing I want to do? I want to fillet the edges. So I get under sketch, I get the fillet tool. I click on this edge and this edge, it rounds it. I'm not going to put the parameter in till we go all the way around, and then I'll put the parameter in one time and it'll put on all of these. So I go clickety clickety. I got another rounding. Click, click. That one's rounded. Click, click, that one's rounded. Okay, now what I should do here, I'll go ahead and click enter, and now I will get the select tool, and you see this is the dimension already on there. I'll click on that, and I want this, what do we call it? Corner radius. So I can click here on corner radius, enter, enter. Okay, boom. Now look at what happened. One of the things that you see that happened, and we need to fix this right now because again, we need to be very deliberate. And it's okay, it's not like we skipped something earlier, but now that we have our rectangle formed, what do we need to do? We need to lock the rectangle down in space, because if you look at it right now, it can move all over the place, and you say, well, stop moving it. Yeah, even if I don't move it though, you know what can happen? Something else can move it. You can come in and you can change a dimension, and then it'll pop this thing over in a way that you weren't expecting. And so we need to set some constraints. So I need to say a constraint. I need to constrain this side to be coincident. So what constraint? I'm getting the coincident constraint. Okay, the coincident constraint. This side needs to be coincident with the origin. And let me try that again. Coincident, this side with the origin. All right. What else do I want coincident? I want this side coincident with the origin. All right. Now, look at this. You see what happened when I did that? All the sides turned black. And what that means is it's fully defined. There's nothing ambiguous. It's all fully defined. And in fact, if we come over here and look at our sketch, this sketch 1, which is the name of the sketch, has had a little pin in it. It's like, good job. It's like a gold star saying that you got it done. Okay, so I'm going to clean this up a little bit. I'm going to pull my dimension out here if I can. Why does that dimension not want to come out? There it is. Okay, kind of get it out of the way. All right, now if you think about our box, this is our box. How many rectangles for that profile? Well, there's the outside rectangle, there's the outside of the lip rectangle, and there's the inside of the lip rectangle. So there's 3 rectangles all together. Let's make these. We could redraw them by hand, but it's easier to do an offset. So we're going to come in and we're going to say do an offset. It says offset from where? I say from this, and it guesses that you want it to be bigger, but I want it to be smaller. So to tell it smaller, I put a minus. And then where do I want to go with this? I want it to be minus wall thickness. And I can click on that and say OK. We get very excited because look at this. It put the wall thickness of 2 in. But this is either a quirk or possibly a bug. But I did not put in 2. I put in wall thickness, and it changed that parameter to a constant, the number 2. So I got to come back and edit it and say wall thickness. And I don't have to put a minus this time because the direction was right. So I just click wall thickness, enter, enter. Now what does it say? FX, that's like user defined function, user defined 2. That's what I want to see. Now what else do I need? I need another offset. And I'm going to say a offset, and I'm going to offset from here, and then how far? Well, I want minus what? Not wall thickness, minus lip thickness. LIP thickness. Okay, say okay. And then what did it do? That little quirk again. So we got to come in and say what? This is lip thickness. The second time it takes it for some reason, so I'm not sure why it does that. It could be it does it for a very good reason, but it's just very annoying to me. Okay, look at this, and nothing is blue. It's all black, saying everything is locked down, nailed down. We've been deliberate about constraints. We've been deliberate about dimension. We've been deliberate about position, and we've been deliberate about using parameters. So we have done a good job. Okay, let's call that the bottom of the box. We still need a what? We need a top of the box. All right, guys, at this point you are tempted to come over here and copy and paste and move it, or to set up a pattern and move it across. Man, when you try to move something, it's very unpredictable what it does with all of these constraints and dimensions and parameters that I put in. It might, again, change a parameter to a constant. And so I've tried everything, and I have not gotten a way to create a duplicate of this without it creating some ambiguity and some problems. And so what I have found is it's easier and quicker for me to just draw it again for the top than it is to try to copy it and then go in and find all the problems. And so let's give it a place to copy it to. Okay, and so I guess what I should have done is I should have created another parameter. So I'm going to come up to parameters. Okay, and come down to change parameters. And let's create a parameter called the box gap, and that's just the gap between the boxes. Okay, and let's call that like 20 millimeters. All right, so you can see here I've got a little point at the corner. Let's see if I can draw from that. So what I'm going to do is I'm going to make a line, and let's see if I can snap there. Yeah, it snaps. I come out, I click again, I click the check mark, I click D on the keyboard, I come here, and that I want to be 20, right? No! What do? That needs to be box gap. Okay. All right. Now, what did I just do? I gave myself a little corner out here to lock my next design onto so it's not floating around in space. And even though if I just started here and just put it here, it looks like it's going to sit in place, but then when you start editing it and you start customizing it, it starts behaving in a strange way. So we are going to be deliberate about being very specific where everything is. So we're going to lock this next design to this corner. So what do we want to do again? We want to make a rectangle. I'm going to go faster this time, okay? So we're going to make a rectangle. Click. What do we do? D for dimension. This was what? Width. All right. Enter, enter. This was what? This was length. Enter, enter. Boom. Now what do? We fillet the edges, get fillet, and go click here and here. Click here and here. Click here and here. Click here and here. All right. Now what do? We're going to put that in as corner radius. Okay. All right, boom. And it fixed it there. All right. Now let's make sure we're still locked down to that corner. Yeah, you see how everything is black, and so that still looks good. We now need to do our offsets with the associated annoyance of having to fix them. So we're going to say offset from here, how much? Minus wall thickness. Got it. Enter. All right, and now what do we got to do? We got to go in and fix it, and we got to say wall thickness. Enter, enter. Okay, now we need another one, another offset, and that is going to be offset from here, and this is how much? Minus lip thickness. I can click here, say okay. And then what do? We got to fix it. All right. And this is just this time lip thickness. Okay. And it looks like it likes this. It looks like that it's all locked down. I still have the little push pin on my sketch. All right. I still have my little push pin on my sketch, and so it looks like it's happy. It looks like everything is locked down, and so now we are ready to start extruding, and hopefully this is going to go pretty fast now. So I like to extrude with a little bit more of a perspective view. I'm going to go ahead and say stop sketch because my sketch is done at this point. I'm going to come up and say create what? I'm going to extrude. What do I want to extrude? I'm going to click here and I'm going to click here. How far do I want to pull those up? 2 millimeters. No! I pull them up how far? Wall thickness. Okay. And boom, look at that. That's the bottom of the boxes. Now this is another kind of quirky thing about Fusion 360. After you extrude, it hides your sketches. Man, we're just getting started. How do you turn it back on? Look over here under sketches. Here's your sketch one that we're working on, the light bulb. Click on it. It turns on and we can see them again. All right. Now if we look, this is the bottom of the box. And on the bottom of the box, if you can see, the inside has the lip, the outside does not have the lip. Are you able to see that? You see the lip is on the inside, which means this one I need to extrude how far? So we're going to come create, extrude. How far are we going to extrude this? We are going to extrude, I said that the bottom has the lip on the inside, so it's going to be bottom height plus what? Lip height. Bottom height plus lip height. Okay, boom, there you are. Now this one on the outside ring, that's just going to be the bottom height without the lip height. Okay, so we're going to click on that. We're going to say extrude. Where is that? It's under create, extrude. And what are we going to do here? We are going to say that distance is going to be bottom height. All right, there, boom. Now that is done. That is really, really slick. Okay, now let's come and do this one. If we think about the top, the inside one on the top It's just top height. It doesn't have the lip. The lip is on the outside. So how are we going to extrude? We are going to extrude this. And how far? We are going to extrude it top height. See how fast this goes when you have parameters? All right. And then the outside one, we are going to extrude how far? I'm going to let you think. How far are we going to extrude that? It is going to be top height plus lip height. Top height plus lip height. What do you want to extrude? I want to extrude that. I told you what'll go. Okay, let's try it again. Got unhappy. So what do I want to extrude? I want to extrude that. Okay. And then distance is top height plus lip height. For some reason it didn't take it a while ago, but now it's working. Boom. Look at this, huh? Look at this. You see how I have the little lip on the inside of the bottom and on the outside of the top, and that's always going to fit together. Now, normally in the sketch you want to go in and you want to start playing with your parameters and make sure that they don't break them, and so we will do that on the next part of it, okay? But we're getting now ready to what are we going to have to deal with. Now is when the rubber really meets the road, because what are we going to have to deal with? We're going to have to deal with the hinge, and we've been working like this, or we've been working kind of like this, all right? But you see, I can't sketch in my old friend the XY plane anymore, because I'm going to have to sketch like this, and I'm going to have to do an extrusion, all right? And now you might be tempted to come in and just say, okay, well, let's start sketching on what would this be, the YZ plane. But the problem is I don't want my hinge out here at the YZ plane. I want my hinge here, or I want my hinge here. So I'm going to have to do two different hinge drawings. So where could I put them? Well, I could put them like, how about we'll put them on this inside plane. Yeah, but that's not lined up with the corner. That would be goofy, okay? So where would be my best place to design from? Well, for one hinge, design from the middle of this box, because the hinge is going to be symmetric about that middle, and the middle about this box. So what do we have to do here? And this is where we're getting into what you're really learning in this lesson. This other stuff has been reviewed. What do we need? We need our own new plane to draw on, because these coordinate planes are not in the right spot. I would have to draw it, and then I would have to start, it's floating out there, and then I would have to move it floating in another dimension, and I'm going to get lost. It's like going to be like lost in space. So I'm going to create a plane exactly where I want it. Where do I want it? I want it in the middle of this box. What's another way you could say that? I want it between this plane and this plane, exactly in the middle. So what do? We come up to construct. You could do an offset plane from one side, but then you would have to put an equation in, and I might make a mistake doing the equation. Mid-plane sounds like what I want. I want a plane midway between these two planes, and it will do the math for me. So I'm going to say mid-plane. What do I want? I want this one. And then let's see if I can spin it around. And I'm clicking on the inside ones, right? And now right mouse click OK to get rid of the rotate tool. And that one, boom! Look at that! I've got a plane exactly where I want to work. Okay, and let me go ahead and put one on this other one so I get my plane set up. So what do I want? I want a mid plane, and I want it in the middle between this inside face. Very carefully get your rotate tool, rotate around where you can see that other plane. Right mouse click, say OK, because you want this to stay selected, and now select that one, and boom, look at that. I have my sketch planes now that I can draw on. And now what I want to do is I want to kind of draw this hinge profile, and I want to draw the hinge profile up at the top of the bottom of the box and up at the top of the box. Okay, so I'll put them right in the right spot. So let me go back and let's make sure that I have what you can see there. All right, that looks good. Okay, so what do I want to do now? Enough of this nonsense. Let's start sketching. Now, I don't want to come in. I'm going to get rid of this tool. Okay, I don't want to come in and put it on this sketch because that's the wrong plane. So what do I need to do? I need to say create sketch. Right, now it wants to know where do I want to sketch. Let's sketch on this one. Okay, and what I will want to do is I will now want to start building the hinge, but the problem is this doofus box is in the way. Let's see if I can get rid of that. If I look under bodies, let's see, is that body 1? Yeah, that one was kind of in my way. And so now I have gotten rid of that one. So where do I want? Well, I want the hinge to be right here coming out, but I wouldn't want to do a center circle because it would put the circle into the box. I want the whole circle of the hinge outside. So what do I need to do? I need to come up, I need to draw a circle, but I want a 2-point circle. 1 point will be here. You notice how I'm snapping to come out horizontal, and I'll click there, and then what do? I'm going to dimension it, and then what do I dimension it as? That is hinge diameter. Enter. Boom! Look at that. It did it. I might as well put my other circle. Now this circle can be a center point circle, so I say circle, center point circle. I come out here, I click, I dimension. What do I want this dimension? I want that whole diameter. Enter, enter. Okay, and look at that, it adjusted it. Again, that was a dependent variable, and that actually looks pretty good. Okay, you can see if you look here, this is not going to be a very good hinge. If I only connect it there, it's probably not going to work, right? The hinge is going to fall up. So I need a base here. So I'm going to build a rectangle. I'll say R, and I'm going to come out here and then just kind of draw it, right? Now, I could dimension this, but I really don't want to dimension it because I want to tie these dimensions to these features. So I'm probably better off using constraints. And so, right, what do I want? I want this one always just touching the circle. So what would be a great constraint? A tangent. I want this edge just touching that circle. Boom! That looks good. I want this edge just touching this circle. Boom! Okay, that looks pretty good. That really looks pretty good. Now what we probably need to do is we need to go in and start trimming the stuff before we even think about extruding this. We need to trim it, and so we will come up here and we will get the trim tool, and it's okay to be rounded out here, so I'm going to take the rectangle part off. That looks good. And then here I don't want the top of the rectangle at all, right? That's just slowing me down, so I get rid of that. Okay, and now this part of the circle I don't want. All right, this is what's very important. Again, this is where this is going to be the make or break of your design. Don't just go and start extruding, because what do you see? This sketch is not finished, right? It's not all black. This sketch doesn't have the pen, and so there's some ambiguity in here, and if you came in and you changed a parameter, you could break the model. And so we've got to get some constraints set up. And so let me just show you, like, let's just start looking at some problems. Like, what if I just grab this? Okay, you see how that's moving around in a strange way? Okay, that is moving around in a strange way. Okay, and so I want to undo that. All right, I want to undo that, and what I want to make sure, let me see that again. What is happening that I don't like? Okay, this should be tangent to that line if that's possible, and so I'm going to undo that, and I need to put another tangent in where this, and I'm going to probably have to rotate. Let's just see. Yeah, I can get to that line. No, maybe I cannot. So I want to make sure that I get that right. So I want to say tangent. I want right mouse click, get rid of that tool. Tangent, I want this to be tangent to this. Okay, look at that, boom, it locked it down now. Okay, it looks like it's happy, but I still want to move it around and make sure that everything is gonna be good. And so let me get my select tool and let me see if I can move this. Can I move that point? You know, can I break this by trying to grab it and move it? And it really seems to be locked down. It seems to be happy. I'm going to move this because I don't like when it puts that dimension there. It makes it look like you've got a line segment. That really looks good. Okay, before I go on at this point, I'm going to kind of play around with this a little bit. Now let's go on. Let's go ahead and do the extrude, and then we'll play with it. All right. And so let me kind of get this. All right. Now the first thing we got to think, are we working with the top or are we working with the bottom? Let me turn that other body back on there. Okay, this looks like we are working with the top. Okay, we are working with the top. I think I might have said initially we were going to make that the bottom, but it looks like I made it the top. Okay, so if it's the top, what I'm going to want is I'm going to want to extrude this, and we're going to have to really think about how we do the extrude. This is where we put our thinking cap on, and this is where we use our parameters. All right. Now, if I can, I wish I had a top here somewhere to show you. Okay. This is kind of a doofus top, but I'll show it to you. See that top? Right. The hinge does not start in the middle, right? I'm in the middle, and then I have a hinge offset and I have a hinge offset. So I do not want to start here on my extrude. Okay, so my extrusion is going to be on one side, okay, but it is not going to start from my profile plane. It's going to start offset from my profile plane, and it's going to start offset a certain distance. And so this is where the extrusion starts. And so what I am trying to tell it is, I'm trying to tell it this edge here, where to start it and then where to end it. We got to start it and we got to end it. This one's actually harder than the other one. I kind of wish I'd started with the other one, but that's okay. The other one will be easy once we do this. All right, so where am I going to go? Well, it wants to go that way. We'll let it go that way. How far over should it be? And I guess I better come here and just kind of look at this. Okay. Remember, the whole distance that we have to work with is the flat. Okay, that's the flat. And then how much of the flat are we going to put on the bottom? That would be the bottom fraction or whatever. Okay, and so what I want to do is, if this is the bottom flat times the bottom fraction, that would be this gap. But I want to move over by that gap because I'm starting here. I want to move over that gap divided by 2. Okay, so this is that flat dimension. Okay, this gap is the flat dimension times the bottom fraction. And I want that flat times the bottom fraction divided by 2, and that would be that. So you see, you really got to think about this. If you think about it, it's not that hard. And so what is this? This was the flat width, I guess we called it. Okay. And then times the flat width, and then that is times the bottom fraction. Why are we using the bottom fraction? Okay, why are we using the bottom fraction? And in fact, I should switch you back over there where you can see it. Why are we using the bottom fraction? Because the gap here that we're trying to model is defined by the bottom hinge, not the top. Okay, so I am sorry. I really try to have you on the right screen, but I don't want to start over and redo this video, so you're just going to have to live with this. Okay, so we have we say to start, okay, and I put this in the wrong spot, so that's okay. Let me get rid of this. All right, so let me show you this again. We selected what we wanted to extrude. We want to extrude. We want to start at an offset plane, right? I don't want to start extruding here. I want to start from an offset plane. Well, where is the offset plane? Well, we just said it. It was that gap, or that flat, the flat width, okay? The flat width times the bottom fraction, okay, the flat width times the bottom fraction divided by 2. Okay, that is where we want to start. The flat width times the bottom fraction divided by 2. But you know what else we got to think about? I'm sorry if you think I go too slow. You can skip ahead, but this could confuse someone, so I want to make sure everybody understands it. This is the flat width from where here to here, where we take off the rounded corners. Okay. The part of the hinge that's on the bottom, the other piece, the part that is the other piece, this part here, this is the flat times the bottom fraction. And that is how big the hole is. So the hole should be the flat times the bottom fraction. We want to go from here, so that's divided by 2. But remember, we want to leave a little more gap so that it doesn't fit too tight. So what I'm going to add is, to this number, I'm going to make it just a tiny bit bigger by what? Plus the hinge gap. Okay. That is in the wrong spot. I should have put it here. Plus hinge gap. Okay. And then this one, we need to start over. All right. So what I just defined here was this point here, where it's, sorry. Okay, so what I did was, I'm sorry again, I will be very mindful, but I put in here, this is where we're sketching. This is where I want this extrusion to start. Offset, right? Offset. Offset how much? The flat width times the bottom fraction divided by 2, that's that gap. That's that gap, plus a tiny amount, plus the hinge gap. So that leaves just a little tiny bit of extra space. Boom. Now this start of the extrusion, here, the start of the extrusion is in the right place. Now I have to say, where do you want to go to? How far do you want to go? Well, I don't want to tell it a dimension. I want to take advantage of my drawing. I want to say stop at an object. What object do I want to go to? I want to go out to where the edge of the corner, right where it starts to round, right there. And I'm not clicking randomly. You see how it recognizes it? It lights up a point there. That's that intersection. Click. I hope that worked. That should always go to that intersection. Okay, yes. Look. Why did we do it that way? As I change the dimensions now, this edge is always going to be pinned to that corner. So if I change the rounding, this is going to adjust to always come out to the edge of the corner. So if I change the corner, this isn't going to end up sticking out in air. It's always going to align there. This is design intent. This is thinking about things. Okay, now we could try to redraw the whole thing over here, but I will try. Okay, and then now that we've seen all that, let me right mouse click OK, and let's click OK so we lock that in. Okay, we could do the same thing over here, but I am going to live dangerously. I'm going to try to mirror it. So let's turn that back on. So let's see if we can mirror it. Let's say create a mirror, and since this body has become part of this body, we need to mirror the faces. So I need to select. You got to select carefully. Let me zoom in so make sure you can see. This edge face select, the inside face select, the outside face select, your rotate tool. Don't forget the bottom face. Right mouse click OK. The bottom face. Now we need to rotate. And then what do we need over here? We need this end face. Right mouse click OK, and now select that. So I think that's everything that we want to select. Okay. Come back over here. Right mouse click OK to get rid of the rotate tool. So those 5 faces. Now let's select. So you're saying on the mirror plane, tell it we're going to select the mirror plane. We want to mirror around this. Did that work? Why did that not work? Are you serious? Are you serious? Oh, I see. I didn't select the face right. It selected that edge face. Okay. Let's come back. You see, it selected the edge face and it popped it over on the other side of the edge. And so that's why we need to be careful. Let's turn on these planes. Okay, you see how I made this plane? This is the mid plane. That's the one we want to select. Okay, so let's say select. I'm going to get rid of that old selection. Say select. Boom, now it's out here. I say okay. Boom, look at that. Look at that. It's in the right place. Okay, it is in the right place. And we didn't have to redraw the whole thing. Okay, so now let's just see if we can break this thing. I'm almost afraid to do this because I've got an hour in this video and I don't want to have to restart the whole thing. I'm so afraid. Okay, let's see if we can break it. Okay, so let's say that we make the width 45. Boom, look at that. Okay, you see I changed the width and you see how much smaller those hinges are? But look, bam, they go right to that corner. And even the mirrored one, bam, right to that corner. That is looking really good. What if we make it 35 on this one? Bam, look at that. Let's make the corner radius, let's be crazy. Let's make the corner radius 8. Boom, do you see how those things popped in? Everything is working. The height, you can see that that's not going to matter. The lip height, it's not going to matter. What would be something that would matter? The hinges, we kind of played with those already. This is really good. So we'll play around with it some more trying to break it, but let's put this back. This was what, 65? Okay. And this was 45. Okay. And let's put the corner back at 4. Okay. You see how we did some crazy things there and we never broke our model? All right. Now we need to do the same thing over here, but it's really going to be easier. All right. Now you would be tempted, as I was in the 12 hours I wasted on this getting ready to make this video, to try to take this, right mouse click, okay, to take this drawing that we just did and copy and paste it on this plane. Perhaps project it on this plane, perhaps do all types of other things, but anything I did, I ended up creating something that was more trouble to try to fix and get my constraints back than to just draw it to begin with. So what do we want to do? We want to create a new sketch. So we come here, sketch, create sketch. Why did it not want to create a sketch? Create sketch. Oh, I got to tell it which plane it's waiting. Okay, and this time we want to do it on this plane. Again, this is the mid plane that we created earlier, so now I'm drawing right in the middle of the bottom of the box. So what do I want? I want a circle. So I say sketch circle, and let's see if it'll give us something to pop to. Boom, it's locking onto that line. But I got to remember, I wanted a special circle. I wanted a 2-point circle because, right, I want it to come out. So it's click to the line, I come out, I do D for dimension, and what dimension was that? This was like hinge diameter. Boom, hinge diameter. Okay, what else do we need? C for circle, this will be a center circle, and then D for dimension, come out, dimension that. What crazy dimension was this? This was the hole diameter. Enter. Boom. Look at that. That is looking really good. Then what do? We draw a rectangle, R for rectangle. I click here. I just kind of come out. And now what do? We decided the best way to handle this was with constraints, I believe. So what we said was we want tangent. I want to make this line tangent with a circle. I want to make this line tangent with the circle. And we didn't do this the first time, but we saw that we really needed to, so we went back and did it. But also with this tangent tool, right mouse click OK. Sometimes that rotate tool annoys me. I'm going to click here, and I'm going to click here, and now those are constraints. And now this thing looks fully constrained, and so that's good, but we still need to trim it up. So we're going to come in and we're going to say trim, and I'm going to trim that and that. I'm going to trim the inside off. I'm going to trim this top of the rectangle off all the way across. Boom. Okay, this still looks fully constrained, but man, I'm going to see if I can break this. I'm going to see if I can grab a point and move it anywhere. You see, I'm trying to grab and see if anything will let loose and mess up. And that way, what we're doing is that's kind of what happens when you redimension something. And so you want to really make sure that you're locked down, and it's showing black, and it's showing that that design is pinned down. So that really looks good. Okay, so now what we're ready to do is we are ready to extrude that one. And so let's kind of rotate it where we can see it a little better. And so we are going to say stop sketch. We are going to say create an extrude. What do I want to extrude? I want to extrude this. Okay. On this one, do I want to extrude in one direction or both directions? Man, I might as well do both directions because I'm here in the middle, right? And we're doing that center part of the hinge. And so we're going to say, how about say make it symmetric? Okay. I like the idea of making it symmetric. All right. And so what I will do is I will come out half the length on each side. Okay, so we're going to come out symmetric on both sides. We're going to come out half length. And then what was this? This was the flat width. This was times the bottom fraction, right? Because I can't take that whole width. I can just take the amount that I have, the bottom fraction. Okay. Okay. And then I want divided by 2, all right, because I want half on one side and half on the other. So let's see if we can think about this. All right. Remember the flat width was like from right here, the edge of the round to the edge of the round. That's the flat width. How much of that can I use on the bottom? The half width times the bottom fraction. All right. And then I'm going to come out that much here and that much here. So coming out this way, I can only use half of it. And so that is the reason for the divide by 2. Does that make sense? There's a lot of different ways that you can define this, but you just want to do something that's going to work. And then I can say, okay. All right, so now let's rotate this around. Wow, look at that. This is an excellent parametric design. One couple of real quick bookkeeping things here. If we look underneath here, oh, sometimes the rotate tool breaks my heart. There it is. Okay. Do you see how it'd be nice to kind of round that off right there a little bit? So let's get the modify and let's create a 3D fillet there. And what I want to modify is that. And it wants a number. Let's look like 4. Okay. Let's look at like 3. Okay, 3 looks pretty good. But probably I'm going to see, is this going to let me do this? Let me see if I can create another parameter in the middle of this. Okay. Let me create a fillet round. And let me make the fillet round 3. Okay, I should have thought about that. Let me make the fillet round 3. And now what I need to do is, let's see, is it going to let me edit that? Please tell me. All right, I'm sure that I could undo it and then put it back in, but I'm just going to let that one slide because I want to get on. I want to get a wrap on this video. Okay, this one we'll do more deliberately, so we will come in and we will say create, and we will create a 3D fillet. Where was that silly fillet? Or it's a modify, I'm sorry. Under modify, We will create a 3D fillet. We will create it right there. And then this time we will put in fillet round. Okay. And say, okay, look at that. That looks kind of nice, doesn't it? And let's do another one there. Say modify fillet. Okay. And then we put in for the radius fillet round. Okay. Boom. Look at that. Okay, that is really, really slick. That is all ready to go. Okay, let's look and see if we can break this thing now. Okay, so you see, yeah, it took a little while to do this, and I did a lot of talking, but really most of it was just setting the parameters up. What was the most important thing that we did as far as thinking? Thinking about how to put a plane to draw off of, and seeing that we really wanted it in the middle of each part of the box, one here on the top and one on the bottom. Because if I would have tried to draw from here and start, I would have had to have done a lot of equations to get the various reference points, and I think doing it from the middle really made it work out. Okay, let's see what would happen. All right, let's say, and let me see here if I can get this. Okay, so let's say we change the width to 30. Let's see what happens. Boom! Look at that. Nothing broke. Do you see how everything adjusted very nicely? This and this is still the right gap with that. What if we put like a 6 radius on there? Curve radius. Look at that. It further adjusted. These got closer together and smaller. Everything adapted perfectly. I kind of actually like, for some reason, that box looks very attractive to me. What if I came in and made the top 25? Boom. It's almost like I feel like I'm making one of those old style cigarette lighters here. Is what it's almost starting to look like. All right, let's more parameters. What if I change, oh, this would be one. What if I change the hinge diameter to 6? Let's see what happens. Boom. And even it would have been fair if this fillet hadn't worked because I didn't really do the parameter on it right. Okay, but that is all looking good. It's all looking very, very good. What would be something else that might make a difference? What wall thickness? What if we made the wall thickness 4? Okay, boom, look at that. You can see that everything adjusted and everything looks very good. What if I wanted to move it over a little bit? Remember how I put a certain gap between the two? Where was that? That was, where was that silly thing? Corner radius, box height, top height, lip height, wall thickness, flat width, hole diameter, box gap. What if I made that, like put them closer together, 10? Crazy things, if you don't constrain your drawings, can really mess things up. But boom, you see I moved it and all the parts moved together properly. All right, guys, I am really excited. I'm going to set this thing back and I'll go ahead and print it just to make sure. I'm not going to bore you with just making a pin, but you can do a pin extrusion and I can build all 3 of the things at the same time. Guys, this has been a long video, but I hope it helps you. It could be that you guys are all smarter than I am, but man, I'll tell you, I struggled so much learning Fusion 360 just because the guys that used were guys that came from Inventor, and before that they came from AutoCAD, and before that they'd done SolidWorks, and before that they had done the old school stuff. And man, they are so smart and understand stuff so well. They're just throwing stuff at me. And what I can do is I find that I can copy what they do, but then when I do it myself, I can't do it. Okay, if you really want to learn parametric design, I hope you've done this with me. I hope you have drawn this with me. Okay, but what I hope you'll do now is I hope that you will just kill your file and turn the video off and go back and do the whole thing from scratch without watching me, because I think I've gone through it deliberately enough. And other thing, I hope that I was good at explaining why I was doing things the way I was doing them, why I was not just using any parameter, why I was trying to define those parameters so that when we get back here to the hinges, no matter how I change the dimension, always match that gap with just a little bit of margin added in. And so I hope you saw how to think about this thing, and I hope you could do something of this complexity by yourself. We'll move forward. We'll start slowly doing some more complicated things, but I specialize. Maybe I'm a slow learner. I kind of specialize in people, experts in the idea, and I hope, even though this was a long video, that it really helped you. I would really like your feedback down below, man. I don't know, am I just like insulting you in the way that I'm doing this? Is it helpful? Are there things that I'm doing that you're not following? If you would put comments below, what's working, what's not working, that would be helpful to me. If you like this, think about giving it a thumbs up. Think about subscribing to the channel, sharing it with your friends. Okay, we are learning Fusion 360, or we are going to die trying. Paul McWhorter, toptechboy.com. I will talk to you guys later.